Okay, so this is the mock paper 1 talk through of question 19, 2021. Probably a few of those. So, P, M and S are points on a circle, centre O, and RST is a tangent to the circle. I'm told that the angle PSO is 48 degrees. I'm told that MP is equal to MS, and they've kindly marked that with those two little dashes to emphasise that fact on the diagram. And I've asked to work out the size of the angle MST. So MST I might mark on. That's ultimately what I'm trying to find. And to give reasons for each stage of my work. And there's 5 marks available for this question. So there's a lot out there. The fact that I have to give reasons is going to be essential for the 5th mark there. In order for me to get all of those. So I'm going to have to look really carefully, and it's really easy to make mistakes in this question. So for example, it'd be really easy to think that this angle here is 48 degrees, recognizing that you've got an isosceles triangle. Apart from, the 48 degrees isn't fully part of the isosceles triangle, is it? It's only going as far as O, it's not carrying on all the way. We've got this little bit of angle missing. So it would be wrong to say that this was 48 degrees. And so what I would encourage is a trick that's often really useful when you have a circle theorem question that's quite a tricky one, like this one is, and if you're stuck. And that is to use the origin, if the origin's involved, and to using that origin, draw a line. And I'm going to draw a line from P to that origin to make this question a little bit easier, at least to give me something that I can solve. So now I've got another isosceles triangle within that isosceles triangle, and I know it's isosceles because it's the radius. The radius is always going to be equal from the centre of a circle to the circumference. So I can actually add that on to my diagram, and even more so I can say that this is 48 degrees. Okay. Knowing that this is 48 degrees, I can use that the angles in a triangle sum to 180 to state what this angle is here. But as I'm trying to give reasons for each stage of my working, I'm going to slow down a little bit, and I'm just going to say a few things that I've figured out. So I've figured out that the angle SPO is equal to 48 degrees. And I'm also going to figure out from that what the angle POS is. And I know it's going to be 180 minus my 2 lots of 48 degrees, which is going to be 84 degrees, I think. And the reason for that is because angles in a triangle sum to 180 degrees. Let's try and include every reason that we use here. So this is quite nice now because I've got this circle theorem. Okay, if we try and remind ourselves as we go through these with the circle theorems involved, I've got that circle theorem where you have an angle at the centre, and you have maybe 2 other points, and then you have another point, let's say it's over here, and it's that kind of delta shape or Star Trek shape, and this angle here is going to be double this angle here. And what that angle rules called for circle theorems is the angle at the centre is double the angle at the circumference, or subtended at the centre, it's double the angle at the circumference. So I'm going to add my 84 degrees onto my diagram. It's a good idea to do that, to just see the diagram sort of coming to life with more and more information. And knowing that this rule here, I can say that the angle PMS is equal to a half of my 84. So that's going to be 42 degrees. And I'm going to state the reason for that. That's because the angles at the centre is double the angle at the circumference of the circle. Okay. So I've got that my angle PMS is 42 degrees. Let's note that down. And I've got a quadrilateral now. I've got this 4-sided shape, the 1, 2, 3, 4, and I know one of the angles, but I can quickly find out another angle. because angles around a point add to 360 degrees. So I can say that the obtuse angle at O is 360 minus my 84, and that's going to be 5, 10, 6, borrowing 276 degrees. And knowing that the angles in a quadrilateral will sum to 360, and also knowing that by symmetry, we've got this is equal to this, this is equal to this, so by symmetry these two angles must be the same. What I can do is I can state that my angle OSM is equal to my 360 degrees minus my 276 degrees minus my 42 degrees, all divided by 2. That gives me an angle of 21 degrees. What have I used there? I suppose I've used angles. There's 360 degrees in a quadrilateral. We're nearly there. There's one more circle. There's actually two circle theorems we could use at this point. So one of them is a lot nicer than the other, in my opinion. Okay, so one of them involves a tangent, which we were already told about, and maybe our ears pricked up when we heard that there was a tangent to this circle, and the centre. And that is that, and we can perhaps see this here, that a tangent meets the line of the radius going to the centre of a circle at 90 degrees. There's another circle theorem as well that we could use at this point, and it's quite hard to it's difficult to visualise and difficult to properly follow and understand, in my opinion. I think it's the most difficult of the circle theorems. It's the alternate segment theorem. It takes a while to get your head round, but if I draw another tangent to a circle, and then from this point here I just decide to draw a triangle, so I'm going to draw a triangle here and choose another point. Maybe I'll choose this point here and I'll go back to this point here. What that tells me is that this angle here is the same as this angle here. That's the alternate segment. So you could use either of those in your last step here. Let's use the tangent to begin with. So if we use the fact that this angle plus this angle makes 90 degrees, we can do 90 degrees minus this angle, so 90 minus 21 to find out what this angle is. So 90 minus my 21 tells me that this angle here is 69 degrees. If I had instead used the alternate segment theorem, then this angle here must be part of this triangle, seeing as this is the triangle that's been created from that point where it's touched. And so I do my 21 degrees plus my 48 degrees, which is also going to give me 69 degrees. Let's use the tangent, I think. So I can say the angle, what I was trying to find, MST, is equal to my 90 degrees minus my 21 degrees, which is 69 degrees. And the reason for that is a tangent meets a circle at 90 degrees to the origin. Okay, and that's question 19 done, which is one of the most difficult questions in the paper. I'll just pause that there for a second if you want to pause the video yourself and check any of the working. And on to question 20. Question 20's topic is graphical transformations. The diagram shows part of the curve of equation y is some function of x. Okay, it just means as x changes, y changes, which is what we're used to. Okay, as you change the input in your function, you're going to change the coordinates of y usually. So we've got this function plotted. It looks like a quadratic to me. We've been told that the minimum point, that the lowest point that we can see here, is this point here, 3, negative 4. And we're asked to write down the coordinates of the minimum point with the equation y is equal to f of x plus 3. Y equals f of x plus 3 means that whatever y was, it's now had 3 added to it. So if y was 0, then it's now going to be 3. It's going to have moved up by 3. And if y was negative 4 like it is here, it's going to have moved up by 3 here too as well. So we're going to move up to 3 minus 1. The x coordinate hasn't been changed because we've not changed what's gone into the function. What we have changed is what we're adding to the function overall, which is 3. For the f of 2x, the input's happening twice as quickly. It's more difficult to visualize than to understand what happens when we're changing what happens inside a function, because it's usually the exact opposite of what you expect. I'm going to change the x's, so what you might expect if I've got 2x is that perhaps this is going to move to 6 here. It's going to stretch by a factor of 2. But actually the opposite is what happens when you go from an f of x to an f of any number times x. And that means we're going to, instead of moving out by 2, we're going to move in by 1 over 2. So we're going to move in by half. So this is going to become 3 over 2, or 1.5, minus 4. And lastly, f of minus x means that all the positive values that I've put in are now going to become negative, and all the negative values I put in are now going to become positive. So I'm still going to have the same value of my y, but I'm going to have negative 3, negative 4. And that was the answers. That's the answer for that section. Question 21. We had to identify 2 errors in this inequality problem here. Hannah's answered this problem where she's got x plus y is less than or equal to 6, y is greater than or equal to 0, and y is less than x or equal to x plus 2. Here's her answer. She's done solid lines, so that's correct so far. Seeing as these are all less than or equal to 2, she should be using solid lines. But she has done 2 mistakes, and we've got to identify what those mistakes are. Okay? So the first mistake is this line here is actually the line x plus y equals 7. And if she's doing x plus y is less than or equal to 6, she actually is 1 too high for that. So in reality, her line would have looked like this. She shaded the right side of it, but she's not used the right line. So one mistake is that she's used x plus y is less than 7 instead of x plus y is less than or equal to 6. The second mistake that's been used here is we can see that Helen has shaded from this point here as well on the y-axis for y being greater than 0. But in fact what she's done by doing that is shown x is greater than 0. If we choose some x coordinates and y coordinates to sort of make this easier to think about, if y is greater than 0, that would mean anything which has a y coordinate above 0, so that would include this point, but not this point, fall into that category. So as a result, she's shaded in the wrong section. She's done x is less than or equal to 0 rather than y is greater than or equal to 0. Okay? There was a final mistake here as well, which was that she'd done y is greater than x plus 2 rather than y is less than or equal to x plus 2. So there were 3 possible mistakes that you could identify there. Not an easy question in terms of spotting errors. I think for the last 3 questions I'll make an extra video. So I'll stop this there before we do the final video.